Okay, just a second here. Oops. Go to the cloud. And I just have to get my live stream sound hooked up here. Okay. Okay, there we go. Get the microphone going. Okay. Welcome everyone to the Tuesday, November 3rd afternoon session at the Keshe Foundation Spaceship Institute. We're doing a live public broadcasting with questions and answers on the primarily on the energy systems that have been introduced recently by the Keshe Foundation and Mr. Keshe, and what we call the Magrav's power system. And this is part of the blueprint teaching, but this will be just with the Shandor. We'll start off the teaching today, and it'll be primarily with the knowledge seekers that have been involved with this. Okay, I think that's about it. Are you ready to go, Shandor?
Yes, I am. Sorry for unshade face. I was very busy in the past days. Almost day and night working, but I try to show not much of my unshade face, but more about explanations and more about showing, demonstrating how to do.
Hang on a second. I'm not getting my audio. I think I know what the problem is. So, okay, there we go. Sorry, I didn't have your audio. Now we're okay. Go ahead.
Okay, so so many people asked so many questions, for instance, about interpreting what does it mean clockwise or anti-clockwise, because if you look at the same thing from different viewpoints, you can interpret it in a different way. So we would like to clarify that. So what does it mean? And also how to make the coils, what materials are needed, such as like copper wire, and we will need some basic chemicals like caustic soda or sodium hydroxide or simply caustic, or probably you will need some salt, some sea salt, which will be needed for creating gas materials. We will need a bunch of other kind of various metals to make combined gases. So we have here a piece of brass, so we have a bit of iron, we have their hard drive disk, which is according to color, it's covered by molybdenum. And of course, we need a nano-coated materials like plates, coils, etc. And probably we will need a lot of distilled water for making the gas and for washing the nano-coated materials from caustic. And also some tools will be needed. So most of the tools don't need special investment, but or if they need, if you don't have them, you can use them later to other works. One of these very useful tools, it will be a gas burner. There are different models. Some are with piezo spark starter, or you can put it with this extension on a flat surface to have it upwards to work above. So this will be needed to soften the ends of the coils to be able to twist them one on the top of the other. And it will be needed for some measuring tool for length. Optional to have a caliper for checking the copper wire which you buy, or for diameter the other parts which you use for making the coils. For making the coils, you will need a pair of rods or tubes of different diameters, one for the thinner inner coil and the other for the outer coil. So I don't go in details about the construction of the blueprint because that was published, presented during the 1 week. Rather, I'd focus on some special little things which were not presented there. For instance, you need to cut your metal plates to be able to produce your gas. So this is a zinc plate, for instance. I used to cut it in two sides and to make the hooks which will be used to hang them on the top of the plastic container without the need of other clamps. So with just such a clips, you can already make the connection parts, no need for drilling so much. And probably there will be need, when you will have the coils, you will need 3 hard plastic plates, which will be the support for the coils. You will need some drills to drill some holes around, and you will need such a ziplock tires to fix them through the holes to make the construction to be solid. You will need 3 ping pong balls or other small globes of plastic or metal which you nano coat, and then you will put gun space in them. In the middle is like a central sun to provide the plasmatic energy for the coils. And of course you will need various plastic containers, big or smaller, for making the nano coating process. So this kind of plastic box, for instance, just normal polypropylene boxes. And also you can use for gas production some repurposed things like food bucket. This is producing now CO2 gas here. So it has a nano-coated copper coil and it has a zinc plate here on the other side. And on the bottom already you see some CO2 gas. And you need other gases as well. As I said, for making other gases, it's good to have such a higher order materials on the table of elements. For instance, if you can dismember such a hard drives, the older ones were plated with platinum. The newer ones, which you see more brownish, yellowish, like the sunglasses color on it, these are covered with molybdenum. So, and we have got an idea from one of the knowledge seekers to use such a cut bottle which has such a sport tip with a valve. So in case you will have here the guns produced, it will be very open, very easy just to pull this end and to release the content with the liquid just from the bottom. Just an idea. So otherwise you will need some syringe to extract the gas from the containers or buckets. So let's see, the most interesting parts are which wires we use. And you have to know that every maker has different diameter of wires. For instance, I have bought that so-called MCU 2.5 square millimeter wire, which is a standard in Europe. We have here 1.5 square millimeters cross section, not diameter, cross section, or 2.5. This theoretically, according to the rules of the geometry, should have 1.78 millimeters thickness. Just let's see with a caliper how much is in fact. This is actually 1.7 only. So it's right to be used instead of the 14 gauge American wire gauge 14 wire, which should be 1.6 millimeters. So actually it's 0.8 millimeters less than it is according to its specification, which is not a problem because we don't need too heavy wires. Another interesting point, you will need cable, flexible cable with plugs at the ends, and on the other part with such a socket to connect your system, and you connect your power devices to the system. And what's interesting that the cross section of it shall be equal to the cross section of the wires which you use. If you use a thinner cross section, like I bought one and I found it's not good because it's too thin, In that case, you will create a bottleneck for the energy flow, and part of the energy will not go through the wire where it's supposed to go, but it will be reflected back and will produce the heating up of the unit. So whenever you have such technical issues like heating up or other things, so please put your questions. We will try to answer them. So I bought the insulated wire, which I stripped it very easily with a potato peeler. It was very easy to cut away and to pull away the external wire. I arranged it in a way that if I put it on the floor, this can come up winding after winding very freely to be able to twist it very easily. So I put this on the floor. Okay, put this clips away. And here's a very useful tool. It's an electric screwdriver or drill with battery. It's a portable one. This will be very helpful for making the coils. So now about the direction of winding, I made a drawing here. What does it mean, clockwise or counterclockwise? So we look at the start point, which is nearest to us, and to the direction of the flow of the coil, the direction of going the wire, like going away from us. So in this case, if you have it like on the top, you have a counterclockwise. So the turns go in opposite direction to the clock. And at the bottom, you have the clockwise version. So this created a lot of confusion because different people looked at the coil from different ends and they consider differently the same thing as being either clockwise or counterclockwise. Please note, all the coils in the system have to be winded counterclockwise, and also when you twist the wires, you also have to use a counterclockwise twist. So let's put the camera here. I want to show here. Here I have a improvised working bench from some repurposed boards, so it was no problem to drill holes in it. Please don't drill your tables at home. Better get a winch on the table and put a piece of heavy board or plywood in and use that for this purpose. So first of all, I have here holes which are with purpose to hold the wire. So I'm putting the wire through. Okay, here is the end. I hope you can see it. Okay. When we start making a coil, I recommend to use about 25 centimeters or 10 inches free end. So it's about 25 centimeters or 10 inches. Doesn't have to be accurate because later we will trim the wires when we connect together the coils. So this hole will lead the wire, and the wire lies under the desk in a coil in such a way that it can freely released. So now the next tools which are needed, once we have here a pipe for the bigger diameter coil, and we have this for the smaller diameter coil. So for the smaller diameter, it's a bit tricky how to hold the end of the wire. So I'm fixing it into the chuck. I fix the rod into the chuck. Okay, it's fixed. And here we have some free space between the close of the chuck. So I took some steel wire from a coat hanger. You know those coat hangers which are given from the dry cleaners when you clean your suit. Just cut a piece of that and with some pliers just bend it in a way and shape to fit easily here in between these openings between the close of the chuck. This is needed only for the thin coil. For the thicker one, you will not need that because anyway, the chuck will be filled with this 10 millimeters rod. Here I have a 4 millimeters rod. So now I place the end of the rod through the hole. It's a 5 millimeters hole, but it could be 4 or 4.5 millimeters. So it moves easily here in and out. How to make it to position? I'm trying to reposition to let you see more. Okay. And now, okay, I put here this little hook, this U shape, and I try to fix it into the chuck. So it went in. So this was a bit tricky to figure it out. And now we have to press this wire very tightly against the board. So it will be not good to use the thumb. You can use a piece of plastic or piece of wood. I'm using this lighter. So I make one turn only at the beginning. Always the machine turns clockwise, on right, not on left. And we have made a first turn. Then I have here the excessive wire. It's about 25 centimeters. So it will not be good to let it spin around because it will poke my eyes. So I'll put it here. I will turn it here in such a way while it turns to never go with the sharp end into the front. You see, it goes in that direction, so it will not poke my fingers. And now when we start turning it, we keep pressing here to keep the wire well extended. And also we have to push the drill towards the board. So never pull, just keep it pressed as tightly as possible. One of the ways to count is to put here a mark, and you can go slowly and count. Here I have already 1, 2, 3 windings, so I can count 4, 5, 6, 7, 8, 9. So this is one of the ways to count. Or once you count it, you can put here a ruler or something, a spacer, and to make a mark exactly at the place where you want to end the coil, where you have the number of turns. I choose another method for the long coils. I already cut the length of the tube or the 4 millimeter rod at the proper length for having 162 windings. So I can work faster. So always keep pushing, pressing. Don't pull the drill. Push it. So the length finished, and the length is measured according to how many coils I need. Or otherwise, you should put here on this other end, you should put here a centimeter or something with a mark to measure exactly how long you want to go, and to stop when we reach to that mark. So by the way, this coil is 32 centimeters. Okay, so let's put the camera back. So when we reach to the end, we pull out the wire. I release the rod from the chuck. Okay. I put away carefully this precious piece of metal. This will be needed later. I extract the rod. And now, from the other end, I have to leave enough long end, as much as needed for making this end to go through the inside of the coil to make a perfect round circle. So I measured here. I found it safety for me and for having enough long connections. a length of 78 centimeters from 70. Yes, 78 centimeters for the long coil, and for the shorter coils, I will have half of that, so 390. So this is 78 exactly. I don't even need the centimeter for that because I already know this by the eye. And we just have to cut it. And we can start with this end, the next coil. So can produce coil after coil easily. Ouch, this is falling off. Okay. Like the camera. Okay. So here is again one of the coils. So it has a shorter end and it has a longer end. So this long end, by rule of thumb, should be about 1.5 times longer than the length of the coil. This, we shall straighten it. I need telephone pliers to make on the shorter end to turn it back. When we make the nano coating, this has to be turned back, but you can do that later after planning the assembly of the coils according to your own wish. When you think about how you interconnect the wires, and you can trim this according to the length. Usually for the exit of the coil, I leave only 5 centimeters, and for the entrance of the for the exit, I leave 15 centimeters or 20 centimeters, plus how much is needed to find its place. And for the entry of a larger coil, it's enough only 5 centimeters just to have a way to twist up the end of the other. So now this is the first one, and if you do the nano coating with heat, like Philippine does, in that case you can just heat it up and nano coat it by heat. Otherwise, if you use caustic, the caustic will not go inside the windings, between the windings. So we have to make a spacing. So I measured, I calculated that I'd wish to have the coil, the longer coil of the length of 48 centimeters. So I put here a mark on, my desk, 48 centimeters. As you can see, it is there. That is the small mark. I hold the one end of the coil with my pliers here. I hold that to the mark, and I'm pulling with my hand the other until I reach to the desired length. And this is a hard, tough wire. It's not easy to extend it. So it comes back a few centimeters, so I have to pull it several times to adjust it until it reaches exactly the dimension which I want. Okay. Once more. It's okay. If we pulled accidentally too much, we can still push them together, or to correct if there is need for uniformity. So this is one coil. So now let's see how to make the larger coil. Meanwhile, I always take care about the wire because it can mess up sometimes. So if this happened, we have to arrange it again nicely. Just let me put it inside again. Little mess of dirt here. I've seen a genuine, very interesting solution when somebody used directly the insulated coil using this technique with the electric screwdriver like I did, but he already fixed with some screws on the back of the board the potato pillar. So in one step, he did the peeling and the twisting. So he saved a couple of hours of peeling the wire. Okay. So let's find again the hole. Okay. Again, we leave here an end of about 10 inches or 25 centimeters for the beginning. And now we don't need this thing, this U-shaped wire, because we will insert the end of the wire here into this orifice which I drilled on the pipe. You have to know that drilling a pipe is rather tricky because the tip of the drill will just tend to slip away. So usually use a flat file to file a flat surface, or you put a piece of plaster or duct tape, which will hold the tip of the drill still until you make the hole. So now we use the other hole, the bigger one. So here will be our machine for making that. And let's insert the wire. We set here 25 centimeters to be free. Okay. We push it there. We fix it into the chuck. And after we have the first turn, again, we wind here the excessive wire in a safe way. Let it freely going. And here we hold it very well still. And we keep pushing it. If you make the short coil, just be sure you put the measure near to the coil on the desk, and you have a mark there where you have the point where to finish the coil, to don't make it too long. In this case, we are making again a long one, so I use the entire length of the pipe. Here is the end. Again, we take it out of the chuck. And we measure about 78 centimeters of free end. For the shorter coil, half will be enough. And we cut it. And here it is, the bigger coil. It's a nice coil. Now it comes the harder part, because we have to release here this end. So if you can get not a pipe but a solid steel bar, maybe you can make a groove here, a cut all along. In that case, it will be easy to take it out. Otherwise, if you have a pipe which would not support such a thing, you have to use the pliers to push through the beginning. So you see, I am pushing and pushing until I have here a small hole that I can insert the ends of the pliers. So I'm pulling a little by little, carefully to not scratch the wire. And when my index finger fits, I can pull it much comfortably. And this was the hardest part of it, how to take out the wire from the middle. So again, we have to extend this to the. Just a second. Oh, sorry. So you see, this is the length which I have chosen, and this is the length of the very tight coil. So when you use the caustic method, you cannot leave it as tight because the caustic will not enter in between the windings. So that's why we have to extend it to make a free space where the caustic to enter. And we do when we do the second phase, the drying phase of the nano coating, to not keep moist between the windings because of the capillarity. So we need uniform conditions. So if you use just the fire for nano coating, you can leave it in this size, because the fire, the high temperature will create anyway, will force the nano coating in between the windings. But if you use the caustic method, you have to extend it to the same length as the previous, just a little more, and that's it. So I have two coils of the same length. Okay, adjust it a little bit. Now insert the shorter coil, the thinner coil in the thicker coil. This is how they go inside each other. And then we have the long wire from the inner coil, this one, and this, if I'm looking to it, it will show to be clockwise. From your side it looks anti-clockwise, but we push the end through the middle of the thinner coil. So not through the bigger coil, but through the smaller coil, to the thinner one. And this has to be pushed until it comes out from the other side. You can see it's here. So from here on I can just pull, pull, pull. And when I pulled these together, we reach to close the ends. I just bend it a little bit to hold them fixed. And here the shape is not very perfect, so we have to adjust it in our hands to make it to be about the same nice round shape. So this may need a little skill and attention. So here we go. So we have the big coil. Same we do for the smaller coil and the big one and the small one. We pair of two coils, one into the other, will make a set, and you will need 3 sets of that. In total 12 coils. So are there any questions about this one? About the coiling?
How much meters do you need to make the 2 coils or the 6 coils?
Repeat, please. I didn't got well.
How much meters do you need of the wires to do the coils?
Good idea. I bought a 100 meters 100 meters roll of MCU 2.5 square millimeters, and I extended them according, but the extension doesn't change the length. And I used the 10 millimeter pipe and the 4 millimeter rod. With these dimensions, I used about 60 meters of wire for making the whole set, and which is weighted exactly 1 kilogram and 60 grams of copper wire, or something like that. 1 kilogram, 100 grams, or something like that.
Thank you very much.
But if you use thinner pipe, not a 10 millimeter one, but 9 millimeter, for instance, probably you will use less. Maybe 50 meters will be enough.
Yeah, this is Richard. I can confirm on that. It's about 60 meters.
Okay. So using 160 turns for the long one and 80 turns for the short one. Or to make it nicer, 162 turns for the long and 81 turns for the short. Because coils are very good to be a multiple of number 9. So number of turns shall be in multiple of number 9 for having the best matching. This is another theory, but it's a very useful thing to know. Okay, now the next thing which you have to do with these coils, when these are all cut, So you have to figure out how you interconnect them. Yes, yes. Yes, please.
Hello, Mr. Sandor.
Yes. Hello.
Yes. How are you? Um, about the clockwise, and you hear me? Hello?
Maybe about the drill. So the drill can go left or right, clockwise or anti-clockwise. When I make the anti-clockwise coils, the drill turns clockwise. So the drill turns right always. It's like when you make a drill with a, or like when you turn in a screw. It's in direction clockwise, rotating, but because you're making the coil not coming closer to you, but going away from you, the coil will become counterclockwise. So that makes a difference. So the drill turns clockwise, right, technical right direction.
Okay, about the diagram in the blueprint, is it right or is it wrong? About
There
the
are some
blueprint
mistakes, there are
diagram
some
of the
errors. The text is correct, it says counterclockwise, but the pictures of the coil, it seems they need to be reviewed because they show clockwise coils and not anti-clockwise coils. So that will be
Can
reviewed.
you show the end of the coil closer to the camera, please?
Yes, please.
Sure. Yes, part, yeah. Okay, wait a minute.
It's hard for us to see there, Shandor. Do you have a? Well, you can. Okay, it's starting to clear up a bit.
Okay, it seems okay. When it finished, it's turning clockwise, Isn't it? But
It's anti-clockwise. So here I have the beginning of the coil and it's going toward my fingers. It's going away from me.
Okay, so it's anti-clockwise. Okay, I understand.
Yes, it's anti-clockwise, and I have here another wire somewhere to show you more clearly. Can you see here?
No, it's hard to see. You'd have to have it closer, I think. Then it loses focus. Oh, there, yeah. It had focus for a second there.
Okay, I can see it now. I can see it. And what diameter of the bar are you using? Outer
4
bar?
millimeter, 4 millimeter for the inner, and 10 millimeter for the outer.
And when you put them inside, they are not touching.
No.
There's a bit gap between them.
Yes, because I do the nano coating not by fire, I do by caustic, and it needs to penetrate.
All right.
Here is another example, counterclockwise, so this you can see it better.
Okay, mine I like those, yes. Yes, they are like that. Okay, because you have to point your finger towards you, so it means current is coming towards you, and it's uncoiling. So
it's coming from me and it's going to there, and then it's going anti-clockwise. So I am the source and that's the target.
Okay, and where do you put the longer part of the wire?
So the longer part of the wire will go inside itself.
Which end, please? Which end? Yes, but when you start it with a shorter one. So when you finish,
I start with the short. At the end, I have the long one.
Long one.
Can I break in, Sandor?
Yes, please.
Everybody is confused about this long end of the inner coil that has to go through again. It doesn't really matter what kind and what part you take and you put through. There's only one hole to stick it in. So no mistakes on that part. No mistakes. It's an impossibility to make a mistake with that. So you can only make mistakes with making the coil counterclockwise or clockwise rotation. Because when you make it around a rod, you wind it, it's fixed. It's or a counterclockwise or a clockwise. So if you make the mistake of making clockwise rotated coils, you have to unwrap or make new ones.
Make
You
new
need
ones on the other
counterclockwise.
other purpose.
That's right.
You may use it for making guns, for instance.
Yeah, for any other possibilities. So don't throw them away. I would suggest not throwing them away. But if you don't have anything else, unwrap them and recoil them to be counterclockwise. And with the extra wire going through, there is another orientation for that one. But we don't want to get confused with that. So that has something with the stacking and the orientation towards the total building of the 3 reactors. But it has nothing to do with making the coil. It does have something to do with connecting the inner and the outer coil together, but not in this stage of making a coil. There's no difference. So there's just a counterclockwise rotated coil with a string going, with a wire going through it from the inner coil. That's it. No fancy stuff.
About interconnecting the coils, I think before to trim the ends, it's good to think about. Unfortunately, you cannot interconnect them before the nanocoating, but it's good to cut them at the right size before to do the nanocoating. When it's already coated, you don't want to cut it. You have to have it already ready. So here is a pair which I made. So this will be the position inside, the small coil in the long side. And okay, let me see, it's from which view to which view.
Sandor, may I ask you something?
Yeah, of course, always.
Hello, I'm Leo Jukovic. Can you just confirm that the long edge, that has to pass inside is only for the inner coil?
Yes.
Only the inner coil, yeah?
Actually, to the large diameter coil, you don't need that 70 centimeters end. You can make it just a shorter one.
Okay.
So still you need something because you will use about 10, 15 centimeters. It will be winded over the other, and still you need inside the box to go from the bottom to the top to reach to there.
Yeah, for sure. That is obvious. And if I just can add something, because that helped me a lot to understand the anti-clockwise and clockwise for people that are still confused. The point is when you take the coil, any coil from any edge, because actually from any edge, so from the edge you got, if you go to the other side, it goes clockwise, whatever is the edge you have. So for the people to have, that's normally very easy to know what is clockwise and counterclockwise.
So you look from the top to it.
Yeah, you look from one of the edge. If you just take you coil, you just take it from. Okay, can you see my video if I plug my video here?
Yes.
Okay, I'm here. So you see, I just have my coil like that. Okay, and so when you see like me now, when I see from front, I can see that it goes counterclockwise to the other side. That's very easy. And
Exactly.
if I take the other side, it's actually exactly the same. So there is no error possible. Okay, just I knew it. I know you knew it. You know it is just for people to clarify for the people.
Thank you very much.
Yeah, you're welcome. Thank you for clarifying too, Sandor.
Okay.
Yes, Sandor.
So there's no difference with the longer one in the beginning or at the end. So because then you decide that you put the set inside the inner tube, so there shouldn't be any problem whether the
70 centimeters in the beginning or at the end?
Yes. So now when you connect the wires together, so you need here a length about the distance which is between the big coil and the short coil. For a short system, and which you will wind on it, that has to be longer. So if I'm having this an entrance point for the big coil, for the larger magnetical coil, and I have here an exit point. Let's see where it is. Here is the this longer one. It's the exit point of this smaller coil. In that case, I make this maybe 4 times longer than this one to be able to twist around it maybe 10 times. So you can make them shorter, doesn't need to be too long. For the entrance to the system, I using the long one to be able to connect wherever is needed to circuit breaker. Or to
okay, since you are using 2.5 cross-section area on that.
Yes, yes. And this is
what is the diameter of the coil now, of the bigger coil? Since you are using 2.5 millimeters.
Just a second. With the spacing,
so how much is your diameter?
It's about 16 centimeters or 6 inches. And for the inner coil, it's about 8 centimeters.
Okay, but about the
it depends on the spacing
diameter of the coil itself, not when you coil it.
But you see, here the spacing became just like the thickness of this blade. So when you turn it in a circle, here you have a bigger gap, and here you have a smaller. And this is just the thickness of this thin blade. And this is needed for caustic to get in.
I'm talking about the diameter of the coil when you coil it around
the diameter.
Copper. Yes.
So if you had a 10 millimeter rod inside and you put this on, it adds twice the thickness of that wire. So this is 14.5 millimeters. So it's a little bit released from the tightness.
It didn't make any difference because Mr. Keshe says it should be 12 millimeter, you know. It shouldn't make any difference.
Yes, if you had a gauge 14 wire.
Because
and you get the thinner rod. So you can choose different versions. So you can make it smaller, use less materials. If you use not a 10 millimeter pattern, but you use a thinner one.
And how much is the diameter of the inner one?
Okay, so this inside rod was 4 millimeter, and let's make sure we find a piece. Here is one. This is 7.2 millimeters.
Oh, it's all right. Larger than Mr. Keshe said, but it should be all right. Shouldn't make any difference.
It's approximative. It's not carved in stone, so it's not something very strict.
Okay.
You can make from thinner wire, from thicker wire. Of course, this gauge 14 was or 1.6 millimeter diameter was found as an optimal.
Okay,
not wasting too much material and still getting enough output.
Very good. Something else about the thermostat protector. Inside.
We will come back to that also. So because the coils may heat up, you don't want to burn your system. So you need a thermostat switch.
Is it a thermal overload or just a thermal setting like MCB, you know, miniature circuit breaker? Because
yeah, so it's very good to use a
circuit
breaker, an MCB. You have a circuit breaker with several contacts, which you power on, power off. You make the on-off switch, and when you turn it off, it will short the capacitors through a resistor to discharge them. It's recommended.
Because an MCB, if it trips, you have to reset it yourself. It don't reset by itself.
It depends on the construction, of course. So you have to reset it. So you need an on-off button. It will not reset by itself. It's
it should be okay. Should be.
You can make your own circuit. So the thermal switch just gives the command to the microcircuit breaker whether to go off or on.
Okay, so if it's a 2 kilowatt rating, a 13 amp MCB should be used. If it's a 2 kilowatt, it should be about 10 amp, sorry, a 10 amp MCB should be used.
Yeah, so I recommend, according to the gauge of wire, if you use 2.5 millimeter wire, in that case to use a 20 amps or 25 amps.
Okay, all right.
If you have 1.5 millimeter cross section wire, thinner wire, I have here some also, which is the 1.5 millimeter, which is about 1.35, 1.4 millimeter in diameter. In that case, this is good for 16 amps.
Okay, we follow, okay.
When you buy the wire, usually in the box of the wire, it's written for how many amps is recommended, at least in Europe. And it's no reason to make a too powerful one if the wires in your wall are not so thick. So if your wires in the wall are 1.5, you don't use 2.5 here. Just the same to match them. And here you will have problem with finding a proper cord because these cords are 0.75 or 1 square millimeter, very rare 1.5 millimeter. I didn't find yet 2.5 millimeter, which is not flexible, maybe a heavy duty one with 5 wires and not with 3. But you will need it as you want to plug, unplug, and outplug.
It's important the main cord should be 2.5 millimeter.
Yeah, it should be the same. If you make a stricture, if you make a bottleneck, in that case, the power will not go out. It will be reflected partially, and it will cause the heat up of the system.
And that thing Mr. Keshe mentioned it, they had to change all the main cords, you know, because
exactly for this reason.
That for a reason, yes. Thank you very much.
You're welcome. Okay, let's go further. So when you will try to join the coils and you will start doing it, you will get your own questions, how to solve that. So the problem is that this copper wire, when you want to twist it, one on the top of the other, you have a short piece, just for showing, you try twisting it, and it doesn't twist well because it's very tough, you see? It's almost impossible to twist it correctly. You need a very strong power. And for that, there is an easy method. Yes? Okay, this is very welcome, and we can talk. I think it's about the interpretation of clockwise and anti-clockwise in different viewpoints. Yes?
I think
okay,
I just found out. Okay, so I just found out that we have to think about the flow. We are concentrating on the wire, and the wire is what we're hung up on, and we're thinking about it incorrectly. So
anyway, we will discuss that.
So I wanted them to come in here so they can explain further, and we can get our the questions that this is plaguing really a lot of people. So let's get these questions answered to the people that are actually making the units or manufacturing. So
okay, meanwhile, I'm consuming the gas beans, and you can continue afterwards, but I like to say what I'm doing here, and after that, I let the microphone to you to run answer. So there is a trick to soften the wire. You heat it up to red color, and that softens, it anneals the wire. And you go slowly, start from the end and go to inside. Of course, it's more economical if you have a heat-resistant plate, for instance, a ceramic tile, a ceramic floor tile, and you heat over that. You will not waste so much heat like I'm doing now with the wire on the air. Thus, I have no such thing available here in this room. This is not a workshop, this is just a living room, so please consider. So we are going to heat up the wire. Maybe I need a bigger flame. I'm watching to see the red color where I'm heating it. Okay. And now safety. Never put the flame in direction of something flammable. And the second, the hot metal looks like the cold metal, so don't touch it. Leave it to cool. So you can speed up the cooling if you put it in some water, and then you will see the copper will crack off the coating of it. Yes, it's hot, so don't touch it yet.
Sandor,
Yes.
can you check when you are heating the copper? Can you check if the flame turns green?
No, it doesn't.
Because I think when the flame, when it turns green, the temperature should be all right. That's when we used to use the soldering iron, the old soldering iron, remember, to
Yes.
heat the solder.
Yes.
And we used to solder wires. They used to tell us when it turns green, the flame, it means the copper is at the right temperature. I don't know if it applies to this case
It depends of the copper, and depends of the gas on the flame. So what happens actually, it turns green when the copper starts burning off. See here that the flame turns red, not green. And it's really hot, as you see.
And the copper shouldn't turn red hot, shouldn't turn red hot. Or else, as Mr. Keshe said, it will destroy the...
If you make heating for nano coating, should not turn red hot. But if you make heating not for nano coating, but of softening it, it shall turn red hot. Now we are not coating it, we are softening it.
Why?
Just I said before, this wire is very hard, and it's very hard to twist it when you make the connection.
Okay, I got it.
Okay, shall I put it under the tap water to not let you wait so much? Okay, so already I cooled it. Okay, when you work on them, usually you heat one, you put it on the floor or something which doesn't burn, not on your carpet. And now I want to show you the difference. So this end, it was not heat treated, this was heat treated. So now you see, I'm trying to bend this to a circle, and it comes to this one. I'm trying to do this one, it goes like this small. You see the difference?
Which one is the hardest?
This is hard, this is soft. So this will be easy when you have to turn one on the top of the other. If you will twist it so many times, it will harden back. You have to know about that. And you see, if you heat it red hot, that blackness will come off very easily. So what we want to see here, whether we can twist it easily, one on the top of the other. And that was our purpose. So now, if the wire is properly softened, just without using special tools, just with your hands, it's very easy to twist it. So before to do the nano coating, you have to soften. sorry, you have to soften the ends of the wire over the flame to be able to twist them later when you have to join them together. See, now it's easy to make a twist.
Because it's softer now.
Yes, of course. And now, for instance, if I unwind it, we can measure how much length is needed for making a healthy twist of 1, 2, 3, 4, 5, 6, 7, 8, 9, or maybe 10 turns.
Are you using the electrical wire, the one you removed the insulation from?
I bought insulated cable, MCU 2.5, and I removed the insulation by using a potato peeler, so it's now uninsulated.
It's hard, eh? That wire is hard.
Not magnetic wire, so not magnet wire, not a wire for transformers, which is enameled, but the blank copper, the bare copper. It's the bare copper needed.
About the magnetic wire.
Not good.
If we use that wire and then we burn it, does it burn? You know, the covering? You think?
Yeah, where to burn it? On the street in the city of Budapest? It's not a good thing, not a good idea.
No.
I'm living in a blockhouse. I have no yard, and furthermore, burning those things, it makes a lot of poison pollutants in the air. It's not very healthy.
If I put it in an oven, you know, an industrial
Okay, what you do with the fumes? You can do it, of course. Many people do it, but it's a dirty job, which I don't like.
You think all the covering insulation will be removed from the magnetic wire by using the oven?
Try it. Anyway, the wire will get very soft, so it will be very hard to keep the shape of the coils, but it will be easier to make the coils. But if possible, get just buy some wire which is already a bare wire. So now let's see this portion. How long should it be? If I can straighten it.
That's very hard.
I will cut it here because I want to see this length, how much to be. I'm going to straighten it and to see how much. So about 10 centimeters, it's enough to make the coils. I mean to make the turns to connect together, for making a connection. About 10 centimeters is safe, or 8 centimeters it's enough. Plus you have the to twist it. Okay, now always go to the GAN's production. Yeah, very good. And meanwhile, we have so many questions which we have to reply later. So, yes, Renan, please. Yeah, so here's my understanding of clockwise and counterclockwise. So please explain your understanding of what is called counterclockwise or clockwise.
If that's the actual question, but let's see what he's got to say about the coils. Hello, Renan. Sounds pretty active there. Hello,
Renan?
Hello?
hello, Renan.
Hello?
Oops.
Hello.
Hi, Renan.
Is Bernie there? Hi, Rick. Hello.
I don't see him yet.
I think he's there already. He's in the. Yes.
What is the name?
Bernie G.
Vern with a V? Vern, I don't see any.
Bernie. V. Bernie.
I don't see a V in there.
Violet. Bernie.
Yeah, there's no V's. There's a U and a
V,
W.
VERNIE. He said he's there now.
Do you see it, Vince? I don't see it under viewers.
No, I don't see him here either.
Show attendees.
Make sure he's in meeting 939-474-503.
Okay. I'll re-log in siya, re-log in. He will re-log in again. I think
Okay.
there's a problem sa audio. It's going to re-log in.
And get him to raise his hand so it's easier to find him.
Yes, sir. Okay. Vern, please raise your hands.
Sandor?
Hello.
Yeah, hello. Sorry, it's Leo. Just a very short question. I just wanted to know if you nanocode the coils
Vern,
as they are, or if you disassemble everything.
First, you cut them, you adjust the ends, how long you want, and then, of course, the coils are assembled but not twisted together. You cannot join them together. Then you nanocoat them. After nanocoating, you put them into the soup of guns, and after the treatment, you twist them together. And when
after you assembly them, you assemble them, yeah? Only after the guns, you assemble them together. Is that correct?
Yes, and after
Okay.
that you put on the places where you twisted, you put a few drops of cold caustic to repair any damage would be happen to the nano coatings.
Yeah, I remember that. But the unit has to be disassembled to be nanocoated and to apply the guns on it.
Yes, because if they are twisted together tightly, the caustic will not get inside the wires.
That's what I thought too. Okay, yeah. So that's a major and very important information for the people, because I'm sure a lot of people are nanocoating their unit already mounted.
Yes, so we are learning from our successful actions and from our mistakes too. Part of the learning.
Exactly. I agree. Thank you for clarifying again. I stop the voice now. Thank you.
You are welcome. So please buy some copper wire in excess because it might happen that you will waste a few meters.
Buy some what? Did you say?
Buy some extra spare copper wire. Not just what you calculate it's needed.
No worry, you know, I bought like
happen to
100 meters. I have 100 meters of copper, no worry.
It's very good. 60
what I
meters
need
for the system, 40 meters for learning.
Yeah, exactly.
But you need also for capacitors, maybe 5-6 meters.
Okay,
So
yeah.
up to 70 meters for a system.
Yeah, that's it. I bought roughly 100 meters because I thought that I will use 80 meters globally for everything. So I took 20 meters extra that I'm sure I'm on the good side. So
very good. And with demonstration, I used up too much, so I have to rush again to do another coil of 100 meters to continue capacitors.
I understand. Okay, thank you, Sander, for everything, and I'm still following your video. That's very good. Thank you.
Renan and Solomon.
I think we're still waiting for.
Did you see him in the participants? Correct?
Yes.
No.
Sendo.
Yes, hello.
Yeah, Sendo, your clockwise and anti-clockwise is wrong. I'm sorry. Maybe it's
no
my
problem.
mistake.
Please teach me.
Because if you start your coil from below, is counterclockwise.
Why you start from below? I'm starting from my viewpoint of the creator and going forward away.
Okay, you just check your coil clockwise is starting from below. If it's starting from below,
I have no below. It's horizontal.
No, the long coil, the long coil. The long coil, if you're starting from below, it is counterclockwise. Yeah, I'm very sure.
I have no below and not above.
No, if you were to put your rod, okay, if you go below, is counterclockwise.
No, it depends of do you get the wire from left or from right? If you get it from right, it will come below. If you put it from left side, it will be above. You see?
When you start, if you go below, when you start, okay, when you start, you go below, it is counterclockwise. It is confirmed.
Okay, let me show you.
Yeah.
Let me show you. I put my camera here to clarify, because you are right and I am also right. Both we are right.
Okay. We learn from each other then.
Yes. So here is my rod. You see? And if I put a wire here in this hole, just I need a wire which is straightened. Oh, sorry, I have to use a new wire. Just I'm using now a solder wire for making it easier. Okay. It's too thick, it doesn't fit well into the hole. So you say, if I go from here
clockwise,
and it's from above, you see, it gets this. Just a second, I have to break the wire. Okay. I have to pull it through, otherwise it will not work. Okay. I'm pulling it through. I start from above. You see, and I'm twisting it, and twisting, and twisting. So
you
will
can
have
see
from here an anti-clockwise. You said it should come from above, but if it comes from the other hole, it will become below.
Yeah. So now you see your coil, the two coil is running anti-clockwise.
This is the purpose. I started from above, as you said.
So
but earlier I started from the other hole, from the right side, not from the left. And if I turn that, it comes from below. It's the same coil. Just if I turn this one, you say, if it comes.
Because you are confused with the other side. You don't confuse with the other side. Okay?
I use this hole when I made the coils.
Yeah, don't
think about above or below. Look at the end result, whether that's okay or not.
Yeah, but you must see all your coil is the one that you're doing now. Also, is the running is clockwise or not clockwise?
I think we should clarify with Renan whether things are supposed to be clockwise and counterclockwise and so on to start with before we get into it more involved.
Can you see it?
Okay, Nana is here.
Sorry, Sendo. We let maybe Renan can clarify better.
Yes, please. So I let this interpretation about clockwise and anti-clockwise, which I understood. Yes. And if you have a different understanding, please teach me. How is your understanding?
The understanding is not about that, Shandor, so far as I know. The understanding is whether we should be using counterclockwise or clockwise coils in the actual construction. So we shouldn't be teaching.
All the week it was told all the coils shall be counterclockwise and counterclockwise and counterclockwise.
Okay, well, let's see what Renan has to say about that, because it's his pictures that were used in the blueprint that are opposite to everything that you've been teaching. So let's see what he has to say.
Okay, so Nana will be the one to present the proper coiling, what we are doing here in the Philippines. Are you there, Nana?
Yes, I'm here.
Okay.
Hello.
Can we see the picture? Okay. You can go ahead, Nana.
Okay, I'll just share some. I'll share a finished coil. Okay, here it is. Can you see the photograph now?
Yes.
Okay. In winding the coil, what part of the wire that you'll use to wind into a coil is the end or the straight part of the wire. You don't have to use as reference on the finished part of the wire, which is the already coiled part of the wire. So the direction of clockwise or counterclockwise should be on where you push that end of the wire to form a coil. So in this case, if you look at this end, if you'll continue this to form into another coil, if you face this part of the coil, you'll push this straight part of the wire so it will curl to form a coil in the direction that is opposite to that of the direction of a clock hand.
Okay, in your way, which is the beginning of the coil? Which is the end where you started?
When you start from the left side, you go to the right.
So this is the, okay,
you
this is
wind,
looking at the end point and not at the starting point. That's our misunderstanding.
Okay, when you wind the wire, you have to start from the left going to the right. That's how you wind the wire.
What do
Then
you, what do you mean by left and right? I don't understand what you mean by
So the
going
only
left
difference
and
here
going
is
right.
when we make the actual coil, the center wire has to be round counterclockwise, not clockwise. Is that what you're saying?
You mean the center wire?
Right, because you're wrapping it about in on itself,
Okay.
right?
Okay. No. You misunderstood the construction. When coiling this wire, you have a rod inside it. When you finish the size of this coil is based on the rod where you wind this wire, right?
Right.
Okay. When you start winding this wire, at first you have a straight wire. Then you move. Imagine there is a rod in here. You move below, then go up, then back to towards yourself, then all the way to the right. That's how you wind. When you face the movement from this side going to here to the other side, you face this side, you'll notice that this straight part of the wire is winding on the rod in a counterclockwise direction or in a counterclockwise manner.
Right, and that makes a clockwise coil.
Yes, and it's been like that since the beginning of.
Okay, but we're interested in counterclockwise coils, not clockwise coils. That's the whole point.
Yes, we have to make the counterclockwise coils.
So are you saying these coils are correct or incorrect?
These coils are correct.
Well, these are what we consider to be clockwise coils. We've called these clockwise coils all week.
The question now is, what clock are you referring to? Are you referring to a clock moving towards the left?
This is the whole thing, is we shouldn't be referring to clocks at all when referring to threads of a coil or the winding of a coil. You don't normally say clockwise or anti-clockwise because if there's too many orientation viewpoints, you say either left-hand thread or right-hand thread. There's only two kinds of coils. There's right-hand thread and left-hand thread. That's a common known, it's just a thing they use all over the world as far as there's threads in bolts and nuts and screws that most of them are right-hand thread, almost all are right-hand thread, but you can get left-hand thread. They go backwards to normal threads. and normal
Yeah, but
screws.
we're not talking about threads. We're talking about winding a coil, winding a wire to form into a coil. That's
Yes,
why
but
there's a
your
thing called
coil or
clockwise.
your wire, if you were to say that you have a, you got to have a convention. We don't have a convention when we're talking about winding clockwise and anti-clockwise, because it depends on if you're winding the rod or if you're winding the coil. They're both opposite to each other to start with. And then it depends if you're talking on the back part of the coil or the bottom part of the coil or the top part of the coil. That's opposite as well. So there's chances to make 4 mistakes in that terminology. So it's without pictures that are accurate, we're kind of stuck that way. And I'm not sure now whether the pictures are right or wrong. And what does Mr. Keshe say about this? I don't understand what's going on now. So we have to clarify this somehow. Like this picture here. Is this the correct according to Mr. Keshe? Or is this the opposite according to Mr. Keshe?
Can I ask something? Is that the end point which we are right now looking at? Is that the end point of the coil?
Yes. This end point is the same on the other end point when you face the other end.
Yeah, both ends are exactly the same. There's no difference that way.
Then when you wind this straight part, can you see the mouse pointer?
Yeah.
Okay.
I've got a question about this. How do you call this now? How do you call this now?
Wind this part.
For a clockwise coil.
Yeah.
No.
Clockwise.
When you continue this, when you add another coil here, all you have to do is to push this part. Apply force on this part perpendicular to this wire. You push this so it will form.
No, we're not. We're not talking about the construction. We're talking about not like turn. Okay, if you want to make this on a rod and you turn a rod, you do the opposite direction into creating a the turn of the coil. We understand that, but the discussion would be we're looking now at clockwise rotated or right turn rotated coils.
If they were a screw, they would turn right to tight.
That's right. These are right-hand coils.
What has been explained was that we need a counterclockwise rotated coil for accentuating the magnetic field. Am I correct, guys?
Yes, that's my understanding.
That's my understanding too. So we are actually looking into the counterclockwise rotation, but now we're looking only at clockwise rotated coils or right turn rotated coils you're presenting here in the picture. So the big question is, you're using these type coils in all your systems. What is your output? Does this function? Does it actually not matter if we go clockwise or counterclockwise? Does it really matter because we have this gravitational magnetic field difference? So I would really want to know now, does it matter to do it your way? That would be actually the opposite of being that was explained by Mr. Keshe. And then the question is, does this actually, give me your take on that.
Okay. During our testing, both winding works. The most efficient that gives the most savings is this one.
Wow.
We've been testing this one since August. Now you understand.
Okay, clockwise.
May I say something?
More output? More output with that? Or?
Why don't we just have one of the guys that in the Philippines direct someone right now, and he can wind the coils, and we can just see which way he says is the correct way.
No, it's clear what Ray.
It's quite clear. We can see with the picture. There's
just a mess in explaining
it's obviously wound. It's wound counterclockwise by pulling the wire counterclockwise, but it is a clockwise coil. It is a right thread, normal thread. We call it a
thread.
clockwise coil because you trace the coil from what's facing you, what's facing here. You trace the wire down into the coil, and it goes clockwise when you trace the wire down into the coil. That's the way you
we
normally
agree on
look
that,
at
but
coils.
the biggest question now is why is Mr. Keshe then, saying, that it's anti-clock? I don't.
Well, maybe he is saying it's anti-clockwise in the same way that they are, that you bend the wire anti-clockwise to make the coil, but it's actually a clockwise coil. That's maybe what he's saying. That's what we need to clarify.
Is it because he's left-handed, or?
It's nothing to do with left-handed or right-handed. It's a matter of this convention that people have mistakenly used of pulling the wire toward you when you don't know whether it's the top or bottom that you're pulling toward you. And this clockwise and anti-clockwise, like I say, it depends on your viewpoint. If you're looking at the bottom of the coil or the top of the coil, it's a different situation. And if you're talking about the rod that's rotating or the wire that's rotating around the rod, that they're both opposite to each other as well. So we have chances to make several mistakes with that convention of clockwise and anti-clockwise. And I think we should go to a different convention, meaning like right-hand thread, left-hand thread coil that we end up with. It doesn't matter what technique you use as long as you end up with either whatever is correct, the left-hand or right-hand coil. And there's a chance that both are correct, like we were just saying. Maybe it doesn't make that much of a difference, but maybe it does. Maybe there's subtle differences with changing the emotional content of the room or something like that. I don't know.
Well, my interpretation of the way that Richard coils with that gun is because the spool is in front of you, you're kind of imploding the coil towards yourself. And I think that you're correct, Rick. That's where the discrepancy is coming from. Because the cord is on the opposite side of you and you're pulling it towards you with the drill guns. So I think the best thing that we could do is for someone to have both directions and take a look at them.
I think the best thing to do is ask Mr. Keshe and see if it makes a difference, and see what he says.
Rick, can I try again to show which one is clockwise and which one is not clockwise?
I think we pretty much figured it out, but sure, I don't see why not.
I need the photo from Sendor. Can I see the photo from Sendor where he show clockwise?
His video. There you go.
Yes, correct. So when you want to see clockwise or non-clockwise, you follow the center line.
So I consider which is clockwise and anti-clockwise if I'm looking from the top of the coil.
Yes.
And I follow the directional wire. So this conventionally, I say it's a clockwise, like the clock turns.
But
and
if you see
counterclockwise.
Sendo, if you see from the center, is it the coil clockwise or anti-clockwise? From the center, the second twist, the third twist.
So this is counterclockwise, this is clockwise. And here I turned here a wire in both directions, just like twisting it from the middle to outside. So now can you tell me what is clockwise for you and which is anti-clockwise for you?
Okay, we start with the clockwise. The clockwise below.
Yeah. So this
okay,
is...
you see the center and you wind it. You see whether it's clockwise or anti-clockwise. You wind, you follow the coil.
When I'm winding, I can go either clockwise or anti-clockwise, even though if I'm spinning the rod in one direction, it depends if I start here and go to right or I start here to go to left. If I start here and look, I'm turning this in this direction, you can see it. If I start the coil from here and it goes to here, then the result will be a clockwise coil.
Sendo, you are correct.
From here, and if I go to here, it will get an anti-clockwise coil.
I agree with you. You see the long coil, you follow the coil and tell me if it's clockwise or not clockwise.
I'm not following the coil. I'm following the end of it to tell whether
No,
it's clockwise or
sorry,
anti-clockwise.
Your drawing. You see your drawing in the center from the first to the last. Is it clockwise or anti-clockwise? You just follow.
This,
No, below.
This is clockwise coil. This is clockwise. This is the beginning and this is the end.
Clockwise. This is anti-clockwise.
This is clockwise. Here is also, and this is counterclockwise.
If you follow the coil, it's anti-clockwise.
No, if you follow it, if you start at the beginning of that bottom coil,
it's also anti-clockwise.
No, you start at the beginning and follow it along. You don't move the coil. You're moving your eyes or your impression down through the coil. You cannot go. No, it's clockwise. You cannot go anti-clockwise down that coil. That
from the start, you go from the start. Is it clockwise or anti-clockwise? From the very first.
I don't think the drawing is a help, to be honest, because it's not three-dimensional. So,
Shandor, can you make a big coil out of wire, a big coil, so we can see?
Yes.
Like, you know, about a foot or something in diameter, so we can really see what's going on here.
Okay.
Just found the part of the video where Mr. Keshe is explaining it. Shall I share my screen?
No, Rainer, just leave it there for now, please. Just hold it in the background.
Okay.
Now let's make a big one. So this is what I'm looking from here. I follow the wire and it turns counterclockwise.
Correct. You are very correct, Sando. Sando, you are very correct.
This is I call counterclockwise. Does not matter from which end I'm looking to it.
Correct. You are very correct.
Yeah. So it starts from here and it goes counterclockwise. And this is the other example. This is what I call clockwise. You see the difference?
Can I interrupt? Hello.
Yes, please.
We've been waiting for you.
Yeah, okay.
Thank you.
We're gonna settle this down tomorrow when I'm teaching.
Okay. So in the meantime,
tomorrow morning when we are there, we're gonna settle this clock and anti-clock. What I explained is correct. What all of you are doing is correct. It's just that when you set it, the rest has to be on the same condition, same rotation.
So if we go clockwise, all shall go clockwise. If we go counterclockwise,
yes. Positrons are positrons and electrons are electrons, and they still live and create field and gravity and everything else. I don't know why you lot suddenly got yourself bogged down in this clock and anti-clockwise.
it's no magic in it, just the directional field will be either this or that. It doesn't matter. Here we have
a lot of people trying to, it's just by the picture. We show the picture, I showed it with hand, and tomorrow, first thing we do, we settle this thing for good.
Thank you very much.
Because the technology is confirmed, people are producing energy. It's just that, what do you call it? So if you follow the way it was shown, you should receive the energy. Is Richard online?
Exit ahead.
Have we got Richard online?
He should be, yeah. Richard, do you want to unmute?
Busy unmuting. Yes, I am.
Hi, little young boy. What have you done? You achieved the power?
I was waiting for the coils to dry. I'm now actually setting them up and hooking them up and getting them on power. got the capacitors, I've got the coils. I'm actually in the process of making the first layer and going into the second set coil.
So you haven't tested yet?
I'm going to power it now or tomorrow. Let's say tonight or maybe in an hour or two, three. We'll see.
But
Why is
there's a
on the
guy in
internet? Pardon?
So there's a guy in Facebook, he made already one, and he measures 5.3 kilowatts.
Yes. So what we're going to do tomorrow, we're going to sort this out for good. And you will go through it step by step. And by now, a lot of you should have achieved a lot of things with it, should be ready to test. So move on to the next step. And if there is any problem, tomorrow we will, what do you call it? We will show it, we will explain it. And if you do one thing, everything has to be in the same direction. If you do clockwise, has to be in the same direction. You do anti-clockwise, has to be the same direction. And either way, it should work. But then you have to look which end of the process you are looking for energy. Hello? Are we there?
Yeah, we're still hearing you.
So with this, we sort everything out tomorrow.
Okay, so it sounds like we don't have to take down the blueprint and so on with the.
The blueprint is there to show connections. The blueprint is there. The blueprint has worked. It works. It's different people are pushing different directions. Blueprint is 100% correct. There was a connection which was reconnected and gone back to be reconnected.
I meant, Mr. Keshe, I meant just with the coil direction, the clockwise versus counterclockwise, and which way they should be, and so on. That's been the main thing. Many people have made their coils.
We're gonna show it tomorrow.
Okay.
We're gonna show it tomorrow if there is any problem. But the strange thing is, has anybody winded it the anti-clockwise or the clockwise, and it says it doesn't work?
Well, I'm not sure if people have their systems working yet is the thing, but many people have invested a lot of money into them. So
if you have two coils, one is clockwise, one is anti-clockwise, you might get a problem. But if both of your coils are clockwise or anti-clockwise, you still should get a flux flow. It's a plasma. I don't know why suddenly this matter of physical interaction has come into it.
Right, that makes sense.
But it's good to good to stress that it actually doesn't really matter that you have a clockwise or a counterclockwise rotation as long as you are doing the same thing in one system, or counterclockwise or clockwise.
Get the same results. Yes.
Okay. Is there a difference in performance? Do you already see that now?
Yes, you should see a small change.
No, I mean in performance in the two setups. Like, does the clockwise or the counterclockwise perform differently? Do we already have that confirmed?
Yes, you should see a problem.
Okay.
That's what we think. That's what we've seen.
If you get the combination of the two, you mean?
Yes, you see the problem is, Richard, some people are looking at it from the end of the hand they're making it. Some people looking at the end of the other end, the tube which is coming out.
Okay.
And I'm gonna put an end to this tomorrow, and we see if you need to rewind again, and we'll see, because I know in factory in Philippines, they decided this is the wrong turning and they stopped everything and returned again. But in fact, it doesn't make any difference in the performance if everything is followed in the same pattern.
Okay.
Okay, that's good to know because around 10,000 people a day or so are downloading the blueprints, so it's good to have them
we'll
correct.
carry on. We'll settle this tomorrow morning. I'm gonna sort it out today. We are back home tonight, so we finished in room with all the jobs that came here to do. And I tested the car units and the power units, and the factory is producing them on the same pattern. So we'll see. Are there any other problems?
No, just the confusion.
That was our main issue, and that was a big one. Thank you for that.
The confusion came with the pictures which we put on the blueprint because you're looking at the end of the tube where it comes to you. And everybody looks at it and says, this is clockwise. How come it's anti-clockwise? And I showed it from the hand end. So tomorrow we're going to do it. We take it out of the blueprint the way everybody is happy. And this way we finish this case.
Good.
Thank you, Mr.
Great.
Keshe.
Thank you.
Discuss, you become master of winding. It depends how you conduct it, how you're going to do it. It's all the same. You have to find, if you make it tube and just turn it upside down, it becomes clockwise. What's the difference? We'll finish it tomorrow. We put the whole thing together.
I think half the point there is that we should have realized that it's the flow and not just the direction on which it's wound.
Yeah, because
Right.
you're looking at the matter state. It's like in the factory, the workers don't understand. They're dealing with plasma. What they use clips. And I
Whoops.
explain to them, how can you use clips? It's a plasma. It goes on the cover, not inside the material. So everything has to be dismantled and reorganized in the plasma condition. It takes a long time to change it. You see it the way it goes, and then there's some people see it. If you follow the same thing in every direction, the clockwise or anti-clockwise, but it has to be, even the turn of your coils has to be, then it's okay. When you mix them is when you have the problem. You find a plasma clashing and then you have no flow.
But you might have something else at that point.
No, you just get a flux, but not that effective.
For that purpose.
Yeah, what about maybe we want to deliberately do that for certain functions?
If you follow it the correct way, you should reach the powers the way it should be, and there should be no problem. If somebody has achieved 5.4 kilowatt, which we said that the double traffic can do, cascading is achieved, so nice for the rest to see what it is and how it's been done.
Okay.
We'll sort this out tomorrow. We address this tomorrow.
Okay, very good.
I think we can move on and answer some more questions then. If there's
Sure.
any other questions regarding the functioning of the system now that we have.
I think if any of you who are thinking in going into large quantity of cans and you want to make rapid cans, we can give you a few tips. That what you got to do is, for example, get yourself a small fish pump and blow air into your gas while it's getting produced. If you're connecting it to like electric power to produce high rapid GANs, and that allows the oxidization much better if you can filter it with a high blow. So while you're producing, you're creating oxides. This is what we are doing in the factory. And the units which are coming out for production are the same. There's a lot of refining. This is one of the crudest ways made. We are learning in the process of manufacturing the shortcuts. But That's for production. If you're making one or two for yourselves, it shouldn't be that difficult. The beauty of it is it works now. We see people coming and reporting and getting, and the units coming from the factory working, representing their work. Tomorrow we finish with this situation that everybody understands. We can take everything off the blueprint, take everything off the net, and just put one blueprint to get rid of all the confusion.
Mr. Keshe, I have a question regarding the quick production of GANs. This is Vivek from Singapore. For the nano copper plate and the copper plate, when we put in a nano coated copper plate and a copper plate into the salt solution, we are supposed to get copper oxide GANs, correct?
You're supposed to get copper oxide GANs, yes.
Okay, so what happened is I have put in a nano copper plate and a copper plate into my salt solution, and I connected it to a 1.5 volt battery. Now,
yes, but the thing is, you have to. No. Stop. When you connect nano coated material or non-nano coated material, depends which way you put your negative and positive of the power.
Negative is going to the nano coated.
Yes. Secondly, when you use the power to the plates, if you're using like 1.5 amp, the material which is produced is not really idle. The ideal way is to allow a slow process in a box, copper oxide to appear. Fast production, it really doesn't make much difference even if you put a both non-nano coated plate.
Yes, because the GANs that I'm getting is actually copper colored, not green colored.
Yes, it's copper colored. That's a pure copper GANs. That's a pure copper GANs without oxidization. When you allow a slow process, by the time the nanomaterial separates from the copper plate, it's slow process so much that it already attaches itself to the oxygen in the water. And when you produce 1 or 2 amps or 1 amp and 1 or 2 volts, now you go so fast through the process that there is no time for oxidization. You get a pure GANs of the element. It's the first time man sees atomic structure in a tangible way.
Okay, in order to
this is not a good way. This is not good. If you have such a thing, blow air into it to make it green, to oxidize it.
Okay,
we have this problem in the factory. In the factory, they are producing rapid copper, and it's all copper. If you increase the current, we mix into a nano GANs condition, which is all black.
So
we just create black holes.
Let it oxidize. I just have to blow air into it, let it oxidize.
If you leave it with a shallow water on the top, you will see that the top layer becomes green, oxidizes itself.
Okay.
We've seen this.
Mr. Keshe, what about the application of hot caustic to the copper GANs?
What do you mean?
When you get the copper color, and I've tried it before, you can use hot caustic to oxidize it.
You can do anything to it to oxidize it. But if sometime when you do that, you get nanomaterial at the bottom. Most of your material converts into nanostructure. You don't see it if you look at the bottom of your pot, it's like a black dust.
Okay, thank you very much, Mr. Keshe. I appreciate it.
You're welcome.
Thank you.
Any other question?
How to dry the capacitors?
I'm gonna silence. Carry on teaching.
Did you get the question about capacitors, Mr. Keshe?
No, I just came on.
Okay, well,
I've been in the meeting all day in Rome.
no, I mean, Shandor just mentioned how to dry the capacitors was the question. You're breaking up there a bit.
What's the question?
Okay, how to dry the capacitors. Did you get that? I don't think we're quite getting through here. Hello, Mr. Keshe. How to dry the capacitors?
What is the question?
The question is how to dry the capacitors, the plasma capacitors.
You don't need to dry it. If you dry it, you lose it. Just paste it on. It stays very pasty wet, and in time it dries up. But don't dry it.
Okay.
So to let them wet.
Pardon?
So we just have to let the paste to stay wet and connect it as it is.
Yes, just paste it. This is what we do in the factory. The system works. The only problem you have, we saw even yesterday when we were assembling the new sets, is that your 4 capacitors you put in parallel then becomes like a shock absorber. It just opens up and closes. So you have to find a way that the 4 positive or negative side don't pull out. So you have to find a way like strapping the 4 capacitors together as one unit. We were looking at it yesterday in the factory. But capacitors are one of the easiest things to make. They are unconventional systems. They are not like a solid capacitors, unless you can find a way that you can hold the wires together without them vibrating or pulling out.
To avoid this to get off.
Right. How would you do it in your diagram there, Shandor? You got any ideas?
Yes.
Put
Sure.
a wire across. Oh, don't rub it off! Oh, don't rub it off! You were there!
It was beautiful, wasn't it? It was all there. Just had to connect them together.
Okay, so
Put 2.
how about to fix
Yeah,
them?
put 2 wires and literally push them through and wind it on the top of each other. You wind 1 wire over the 4 of them parallel, like you do in the circuit. Just wind the ends on the bars, on the 2 bars. But the only problem is, how do we keep the bars together that they don't open up? We are using fasteners.
So we need a mechanical fix.
We don't need it. What have you drawn now?
So is it possible?
Oh, yeah,
to
there are
put
4 of them, yeah.
Either on block, either better to put them on a plastic plate and just to need here another piece which to be tightened over such a plastic part which is tightened with screws, for instance, to keep them to hold.
Oh, you can do it as fancy as you like, Sandor.
So mechanically this has to be fixed, otherwise it's easily pulling out.
It is. I'm sure we'll see different ways of doing it. I've seen people twisting the four together at the top and the bottom. Some people do it 2 and 2. All at the end has to be in parallel.
Mr. Keshe?
Yes?
We had a question about the capacitors for the cars also.
For the car, you need only one capacitor, which is on the exit on your magnetical.
Thank you.
You don't need 3 or 4. It's a single capacitor to stop a surge, and that's it.
So one of ideas to make from a copper wire this shape, which has 2 stoppers here, and then to roll the paper inside within these 2, and these 2 will hold the ends. Is that a problem? I'm thinking to make it something this way and to wind here, to roll here the paper with the paste in the middle, and that it will prevent to be pulled out accidentally. Possible. Another way, when you have them already made, assembled, you just can put them into
EVA
epoxy
992.
Is it okay to seal them up?
EVA 992.
Did you mute Mr. Keshe?
Yeah, I did that already. I was looking for the panelist button.
So one of the ways I'm thinking to use a plastic tube. You put it in and you fill it with some epoxy resin, or just as Richard shown, he used over the capacitor just a shrink tube and shrink them together. Just question is how strong hold it has here on the neck to avoid to be pulled out.
But aren't they supposed to sort of dry out gradually by themselves? Isn't that sort of the idea? I think
that's a question.
I think Mr. Keshe was talking about them as a paste, and you just let them dry out after that.
Yes.
I think the ends are sort of kept open to air, but not so that it would ooze out or whatever. So maybe the shrink wrap would work well, and just not totally close the ends, perhaps.
Okay, it's easy to make. Question is which is the most economical way, because you may make here some mechanical support, doesn't matter from what, and you can tie together, for instance, 2 pieces of plastic and tie together with screws or anything to keep this tight here, to avoid this to be pulled apart.
Sandor.
Yes, please.
Sandor, your idea of the plastic tube is very good. If you were to nano coat it, and you have a cap where you can refill.
Possible.
Yes, and also I would like to thank you and Rick for being patient with me. I'm just a foolish old man trying to put a learning point. As long as
I think I got you. I think I got you beat on both the old and the foolish part, so no problem.
Yeah, as long as mankind benefit from what we talk about.
Yeah, whatever we are talking about, we can learn of it. Having
Yes.
view that you can learn.
Thank
Even
you.
if
Thank
something it looks foolish, at least it prevents you to do something to look foolish later.
Yes.
Correct. Even something so simple as winding a coil, you know, it's more than what meets the eye sometimes, so to speak.
Yeah, different cultures may have different ways to view things. For instance, in Europe, when we see a map, we see house blocks and we see streets in between, and we know to find an address by the street. So this is the main street. This is the old street, and so on. In Japan, it's a different culture. The street has no meaning. For them, street is something empty. It's a nothingness. They consider only the house blocks. And that's why they know this group of house blocks has a name, and this house block inside has another name.
Okay, Sando and Rick, thank you very much.
Welcome. You're welcome. Okay, other questions? Still, we have some time of these questions and answers. Sorry,
well, you really.
My desk is shaking.
Yeah, your sound.
So probably I have to buy a special stand just for the camera.
No, your sound broke up there. There was some bandwidth issue that totally made your voice turn into alien voice there.
Sorry, maybe I put my hand over the microphone, which is on the top of the camera. That's why.
Oh, well, that could have done it. Yes, that definitely confused the computer there. Okay, so
sorry for my image is sometimes shaking.
Right, it's okay. So we have a couple of questions, like the age-old question, which came up recently. Can you use the seawater and caustic to make GANs?
Yes, you can. You get some kind of GANs, interesting GANs. Even you can mix sea salt with water and to add caustic. It will give some GANs, but it's one kind of GANs only. We need many kind of GANs. You need a gradient of gases.
But not necessarily all the ones that are in seawater, because, for example, there would be chlorine. You may not want chlorine GANs in there.
No. You have chlorine in the salt. It's a sodium chloride. That's the table salt, yes?
Right.
Already have the chlorine inside. It's no problem.
You
don't need chlorine when you do the nano coating. Which
no,
is different.
What I'm saying is when you put caustic into seawater, into salt water, you could get chlorine GANs out of it, which is not something you would want to have.
It will not do. So.
Okay.
You will get GANs of different things.
Right, so different things
that of magnesium. So what's the most in the salt water, in the seawater? There is sodium, there is magnesium, it's a big quantity, it's potassium, there's calcium, and there are 100 other elements in small.
And well, the biggest one would be chlorine from the CL. That's the highest level in seawater.
You have chlorine, you have
I've been experimenting with chlor. Adding chlor to the procedure with copper copper electrodes, and that actually helps with the oxidization process. But I will not suggest just adding chlor to your procedures, because it can also create chlorine gas.
Yeah.
Well, the thing is, I think Mr. Keshe mentioned that it wouldn't be such a great idea to use that kind of GANs, because it wouldn't be, you're not controlling, you're not getting the the three main kinds of GANs, perhaps you might get dozens and dozens of kinds of GANSes, which is good to have that spread, but it may not be appropriate for the energy device, at least. Is that pretty much the viewpoint, or what would you say about that in terms of, like you mentioned, we can get GANs, but is it the correct GANs for whatever purpose that one has?
You have GANSes of lower order.
Well, I can confirm you later on, because I used to see GANs in the base paste I used to nanocoat my coils and for the capacitors. So I'll come back on that when my coils work or not work.
Okay.
Okay.
So anyway, it's good to have a mixture of GANSes, to have a gradient there. So now the basic ones which we learn to use, it's the CH3 GANs, it's the CO2 GANs, and it's the copper oxide GANs. And what we get from here, from adding together the atomic mass numbers, you get the strength of each. So this is 12 for carbon, 1 for hydrogen, 3 times, it's a strength of 15. CO2, it's 32 for two for two oxygen atoms, which is 16 each, plus 12 for carbon, it's 44. Then for copper, it's 64, and 32, it's 96, for instance. So you have a gradient. It would be highly desirable to have GANSes of higher value elements. For instance, to have of tungsten, to have of neodymium, to have of molybdenum or chromium or whatever else you can get, or from lead or of tin. So you may try to add to your GANs systems also some tin, or to add some materials which will release something else. So this is by its color. I can say it's a molybdenum color. It's a brownish color. It is a hard disks, repurposed hard disks. So I dismember some hard disks. So I got some magnets, and I got some steel plates which are covered on the top with a layer of molybdenum. The older ones were covered with platinum, which is also an excellent material. It's quite better than molybdenum, but it's expensive. You can use.
Here's a relevant question, Sandor. To make the very best GANs, what combination should we use?
I have no definition for the very best. It depends to which environment you want to have the very best. So these three have to be used. So it's a CH3. That's this orange color. You have the CO2 GANs. You have the copper oxide GANs. This is the green, bluish one. This is the copper oxide GANs. So maybe you can see the color better in this way. So here is the CO2 GANs. This is the CH3 GANs. It's very easy to produce it. Use nano-coated copper and some zinc-coated iron, like a zinc mesh or pieces of zinc-coated iron. And ideally, it would be to have some heavier GANSes as well. So that's why you may try with other things also. So always you match nano-coated copper plate with non-coated other materials. Or if you can manage to nano-coat other materials, that would be very interesting instead of just nano-coated copper. So you make heavier elements, GANSes, it means you have more energy inside. But for basic purpose, these three should be fairly enough. So you can get a very good system from that. And that has also advantages because they match also to the GANSes within the human body. You have the CH3 GANs, which is the base of all sugars. It's carbon and hydrogen. So that's matching to the emotional part of man. You have the CO2 gas, which is basically carbon and oxygen, and the carbon is part of the nervous system. And you have this copper gas, and the copper is part of the energy transmission for the muscles. We have copper in our body, very small quantity, but it's pretty enough. So if you have these three gases, you have connection to the entire being of humans or animals. You have connection to the nervous system. You have connection to the lymph through the copper gas, and you have connection to the blood through the CH3 gas. You have a physical, emotional, and soul level connection. Some more questions are here. David Flanagan asked. Thanks.
Mike,
Okay.
Mike told me that with electrolysis and CO2 GANs, you can produce a GANs of everything you want. For example, when you take two silver electrodes and make electrolysis with salt water with a little bit CO2 GANs, you will get silver GANs. Is this right?
I don't know.
Okay.
It may be possible just to use this electrically forced method. But you have to match the proper salt for it also. Not all salts will work with all the metals. You may try for heavier materials to use, for instance, not just sodium salt, but to use a magnesium salt, like an Epsom salt.
I'm using just ocean water.
Yeah, that has a lot of salts, so that's very good. That's already a good mixture. So it contains many other elements. I try to get a focus on it, and it's not easy. Maybe I have to change the position. Oh, it doesn't do autofocus. Okay, now. So this is a Dead Sea salt, of which was extracted the main edible salt. So it's a reduced sodium chloride, only 4 to 6.8%. It has a lot of magnesium chloride, calcium chloride, potassium chloride, magnesium bromide, and so on.
As Mr. Keshe always said, we have to use local things. So when you live near the ocean, just use the water of the sea.
Yes, so we are far from the ocean. So I was glad to find in a shop such a Guérande rough salt. It's from French producers. It's from the Atlantic Ocean. It's just a wet, rough salt. I have put some a little bit here into a plate to show you. So this is its aspect. This is a full, complete ocean salt without anything extracted of it except water. Still, it has a lot of water. You can see the big chunks. Of course, when you dissolve it in distilled water, you'll find some foam floating on the top and some mud going to the bottom. You filter those out. You don't need those. And you have a very good ocean salt. Okay.
Hi everyone, it's Modris.
Yeah. Yes, please.
I just want to add a bit about the seawater and caustic, because there has been many studies done, and what they find that like they was using specific way how to find what is in there. So first of all, when they was testing, they was using some kind of burning type of method. So they was finding first huge amount of silica inside. When they was continue burning it, they was finding the gold, then platinum, the rhodium. Basically, they find all platinum sort of metals inside. So in ocean water, there is all elements inside. It just depends on which amount. And what they found about gold, it was about 30 times more than what they usually find in the mines. So only think like when we make the copper oxide, like we know it's more or less pure. And then I was quite puzzled about that, because if they was using the burning method to figure out what, I thought maybe they was just opening up the plasma. So first there was silica, when they was burning and like applying the heat, I mean it's plasma energy, they was start to absorbing by opening the plasma new elements, which was deeper, you know, with heavier mass. I mean. So, but anyway, what we know in the ocean is everything inside. So just I wanted to add about that applying the caustic on the seawater.
So life organisms have inside their body gases, and you have to know that all life started on this planet in oceans. So the salt of oceans is very favorable for the life forms which we have here. So
And don't forget fishes. Sorry.
Go ahead.
Fishes, they do poo there as well. So there is B12 and all these vitamins inside as well, which comes out.
But you also got to keep in mind that if you were to, say, drink a quart of salt water, you will find the results are quite amazing and unexpected, let's say. So the body doesn't do well with just taking in salt water from the ocean. That kind of salt is not tolerable for, that kind of water is not tolerable for the inside of our body.
Not to drink it.
So that's why they was applying the caustic like that. They was separate the salt from those monatomic elements like GANs, and like that when there was like promoting this sea extraction, there was peoples was absorbing like in 45 days release from the cancers, because and from the what Keshe teach, people's dying not from the cancer but lack of energy, and when they ingesting those things, actually it gives so much energy, so you can keep running. Your body is boost again, and it's have immunity back. So about the salt water.
Okay. Getting a lot of background noise here from your microphone there, Bunkers.
Yeah, strange. Now it's better?
Yeah, it is actually. Thank you. Oh, it's still a bit doing that, but it's okay. Okay, any other questions? We got some questions here. Chris mentions when you're using the butane gas coating and then you GANs the wires, the GANs would not go in between the windings. What about this? I think there's a gap in the wires when you do the GANs and you dip the whole wire assembly in the GANs. Is that basically correct? Do you have some input on that?
So yes, I used to make a spacing between the turns of the coil with purpose to let the stuff go in. I think it's better if you use the wet process of nano coating. Meanwhile, Renan told that in Philippines they use this fire nano coating, and it creates the coating inside. So we don't know how much it will soak in the gas from the soup.
I did one. Sorry.
So probably after heating, the wire gets softer, gets loose a little bit, and when they form it, shape it by hand to be round, some gaps will still exist there.
What I did, I was heated. I coated with heating, and then I put on cold caustic. But I left the wires completely cool down. Then it doesn't lose that black coating. And then I left in cold caustic overnight, and have beautiful coating. Because it's like if there was something loose in it, it's with the caustic. It's kind of goes deeper, and it's made quite nice coating.
Yes, so you can start the process with fire if you have too much gas to waste or charcoals.
I use it home gas.
Ah, it's okay. We have electric
Right.
system, not gas. We have no gas here, so not everybody has that gas. So anyway, there are many ways how to make the nano coating. So one of the ways which I tried it, I put in a caustic solution, the plates to be coated with the negative wire from a battery or from a power source of around 2 volts connected to it, low voltage anyway. And I put the positive wire on some neutral electrode, which can be stainless steel scrubber or a piece of carbon, whatever you have. And you let the current flow through that liquid, through the copper piece for about 30 minutes or an hour until you see its surface became uniform. When you take it out and you put it into your plastic box, just hang it to let it to condition, and it will still make a beautiful nano coating. And just in this case, it's a combined effect of caustic and the electric current, which helps the removal of the top layer of atoms from the surface of the metal. And these top layer atoms, when they depart, not all can leave it, just many remain very near in proximity to the plate, so they get attached through the gravitational magnetical fields, and that's why these nanolayers are created. They are created from atoms which got released from inside. When you heat, also you release atoms. When you put caustic at high temperature, also it releases. When you use electricity, also it releases some. So there are different methods how to do it. And the most beautiful method we'll have when you will have a good plasma source, to just connect them, the copper pieces to the plasma source, and to let the plasma coat it. That would give the most stable nano coating. So there are different ways anyway. I wish to say about the connecting the coils. I've seen there some early versions which were different, but this we clarified with Mr. Keshe on Friday afternoon workshop, how this have to go. So you see the minus the conventional sign for the entry point, and with plus you see the conventional sign for exit point. And we call conventionally the inner coil, the smaller diameter coil, the thinner coils as gravitational, and the thicker coils, which are marked here and drawing with red, we call them magnetic. And now, if you follow the flow of energy from entry to exit, you interconnect the wires always. First, you connect the smaller diameter coil, then it goes from viewing from the top, it goes clockwise. Then it's continued by the blue wire, which is the end, the long end of that coil. It goes again through itself, through the coil. That's the second turn of the gravitational circuit, again clockwise. Then it goes to the larger, longer coils, and also it gets first into the thinner coil, not into the thicker one. Again makes a third turn clockwise, and then you have again, which is marked here with blue, the long end of the coil, which goes again through itself. And then after these 4 turns, you finished with the gravitational part, and from here on you connect it to the magnetical, but not to the right hand, but to the left hand, and you start throwing the energy counterclockwise through the higher diameter, through the thicker coils. So you go one turn anti-clockwise or counterclockwise, then you connect it to the outer circle, and you make the last turn, and you reach to the exit point. So you see you have 4 turns in one direction, which is the gravitational, and 2 turns on the magnetical coils, which are the magnetical. So the gravitational action, the gravitational field forces will be stronger. So it fulfills the conditions of preserving the free plasma inside. Are there questions regarding to that, or is it all clear?
I think, excuse me, I think so. Just so that people know that there is the central wire, and well, you can leave that picture up there if you want, but the central wire, then there's 2 coils around that central wire to make up just the inner, and then there's a central wire and 2 coils around that wire that makes up the outer coil as well. So it's not quite clear sometimes there, but thanks for saying that, Shandor.
So I may try drawing it again to let's rehearse it a bit. So we have entry, which we mark it with minus. This is the entry. This is the conventional direction of the energy flow. We go always first to the smaller diameter coils, then we will go later to the bigger diameter coils, the thicker coils. So the thinner coil, which comes here, this is the inner coil. Of course, this is a coil here. We have this termination end goes again through it. So this is the second turn, and here it comes out. So you have here twice 2 turns for the gravitational. Then you enter into the next thinner coil. You go through. So this is the third turn. And the end of it, it goes again through the middle. And you get here an exit point. So this is the 4th turn in gravitational direction. From here on, we start following in opposite direction. So we go into the larger diameter, into the thicker coil. So this turn is just in the opposite direction. If this is clockwise, this is counterclockwise. And from here, so always we start to do the circle inside, then we go to the outside. And from here on, we have to connect to this one, which makes the outer. And here it goes, second time, again clockwise. And here is the exit. So it looks complicated because so many circles, but in fact, you have entry, you make 1 turn through the coil, 1 turn through the wire, you go to the other thinner coil, you go 1 turn with the coil, and the second with the wire which is inside, and you connect it then in opposite direction flow to the thicker coils, counterclockwise, once in inside and once outside, and you have the exit point. So that's all. You'll find it's a little more complicated about how you connect together the wires, because these are not made of one single wire, but there are several wires that we have to connect them together. So as a basic rule, if you have an entry, a minus from one, so it's an entry point, and you have an exit point from the other, this is a plus, then so this has to be twisted over the other, and the end always is terminated in a loop. So you end the wires in a small loop to not let the energy flow out, but to turn itself to itself. And here, when you make this twist, use the same direction of twist like you did for all the coils. So it doesn't matter they were all clockwise or anti-clockwise, because we had such long discussions earlier. But in the same direction you made these coils, in the same direction you have to make this twist when you connect together the ends of the wires. Okay, is this clear all? May I delete it?
Thanks, Shandor. You just answered a question on the live stream with that.
Okay. And then how to connect all together. This will be the next thing. You have a central sun. This is very important for every coil system. So we have a small sphere or a globe, which is filled with GaNs, and the globe itself shall be nano-coated. So it's the magnetical field of nano-coating which holds the plasma energy of the GaNs inside. So then you have the coils which are here. I have to make them bigger just to keep the right proportions. This is the next. And then you have the bigger coils around. Something like this. Very large schematics. Now, Mr. Keshe told us that you have the diameter. Let me use another color. You have here this diameter of this inner coil. You know, the smaller coil, the shorter one. And this diameter shall determine the distance between the top and the bottom of the system. So if you have here this diameter, that should be identical to the height of the system. So if this is 8 centimeters, for instance, this also has to be 8 centimeters. If this is 5 centimeters, this also has to be 5 centimeters. And the connecting of the wires, it's very easy. You have entrance, which goes here. You have an exit, it goes to the next entrance. You have an exit, which goes to the next entrance, and you have the exit here. So this is about the coils in the system. And when you have all these three connected together, you make the connection to your wires. Somewhere you have to put your capacitors here. So I'd like to share the pictures from the blueprint about that. Let me find the proper file. Yes, I found it. Let me share the screens. So this is how these are put together. So you see, if here the gravitational loop is 5 centimeters and the height between the centers should be also 5 centimeters, 2.5 and 2.5. So if this will be not 5 but 8 centimeters, there you have 4 centimeters and 4 centimeters, total 8. This is construction of the plasma capacitor. And here are different configurations, how you connect the capacitors. So you can, for instance, make just like a bus with entry and exit. You have here the AC power grid in one direction, you have the load in the other direction, and you just interrupt and you put in series your MAGRAP system on the live wire. And for the live wire, you have you will need such a phase detector, which was a big question for many because there are so many phase measuring instruments, and this is a very simple tool. It's a small neon lamp inside a transparent screwdriver in series with a 2 mega ohms resistor. So you put this into the on the wires, and you touch here this with your finger. You will not be shocked because of the 2 mega ohm resistor will reduce to a few microns the current which goes through. And if you reach the live wire, then this should light up. So those who work with electrical things, they are accustomed with it. So I have 3 wires here. This is the earth, it's nothing. This is the ground, it's nothing. And when I touch the live, then I have here a small red light. You see, this is the live wire of the 3 wires. So this is how to use it. Okay, so back to our screen sharing. So one of the ways is to put in series with your live wire the system. There is another way which is very similar, but in one case you have the capacitor to the load side, and the other you put to the power grid side. Does not matter, it works. Or there is the third version, it's same connection, but you put the capacitors here between the entry and exit of the MAGRAP system. So all these systems work, and there is a combination of them, and so on. In case if you use, you make a unit not for the power grid, for the AC power grid, but for your car or for your boat. In that case, it's very simple. You put the capacitor not in parallel, but you put it in series with your circuit. So this is the way to do it. And if you make a very complex system, you may consider to use a circuit breaker to power it off or on. And when you power it off, in that case, the capacitors get discharged through some contacts here. So it's all about it. This is a test setup. Okay. Any questions about the wiring?
I have a electro scooter.
Okay, you use the same settings like in the car, I suppose.
Well, but will I need the batteries?
Yes, sure, you need. So this system is not a substitute for battery. It's adding power to it.
If all goes well, then hopefully there'll be battery type, plasma battery type systems that will be offered in the up and coming, hopefully short time.
That will be in the near future, yes. Okay, soon we reach 5 o'clock, so soon we can wrap up, but there are still some questions. Macias asked, Carl, does your reactor works? So it's question to Carl. Who is Carl? So it's not
sure
clear
about
to
that.
whom he is addressing the question. So
I
very
think he
small.
means Kalel.
Yes, but it was K-A-L, not Kalel, but
okay.
anyway. So anyway, soon we will get many reports of people who are building the reactors right now, and after they'll put them working, they'll be happy to share together with videos, photos, and sharing their results. So it's no reason to make us for us to make a demonstration about these commercial Magravh units, how well they work, because always there will be skeptical people who will suspect that there is a hidden connection to a power source, or there is a battery hidden inside, or we are feeding with radio waves from the exterior, and so on. So best is if just people get the knowledge how to build them, people make them, and everyone will have the result according to his own hands, his own work, and they will be happy to share these results. So EMC version 2 asked, so strange names. Since the argument of clockwise and counterclockwise is inconclusive for now, why? It was very conclusive. Does not matter, just to be uniform within a power unit. If I wanted to test both directions in different system, what might happen if I connected both systems in the same house but on different floors? No problem. No problem will happen. Bernard Langlois asked, I have asked about gold GaNs. My tests have shown it to be very powerful. It seems to draw all the fields, but not sure if it will release the fields. So that's very interesting. If you are reaching gold and you create gold on, so do the tests and please share the results. I have no. Yeah.
Shandor, people are asking on the live stream to
Yes.
show the capacitors. Yes, the capacitors. Can you do like a 1 minute, maybe 2 minute at most crash course in capacitors?
Yeah, I have no the proper materials for it. Just I can show it with some other materials about how to make it.
Or you can draw it
I
if you
try
want to.
make it in the front of this whiteboard, so maybe it will be more visible. Have some contrast here. So we need some straight wires, and this will be nano-coated copper wires. So it will not be this solder wire which I'm using. So I'm using solder wire just for demonstration purpose because it's very soft and I can straighten it many times. So you need 2 pieces of wire. So one of the wires, you just make it in this shape to have the end closed in loop, so you don't let a sharp point pointing out. So this is one of the wires. You get a piece of not such big, such about this size of parchment paper or baking paper. You put on it paste. So you fill it with GaNs paste, pretty dry GaNs paste. A very hard GaNs paste is needed. So those who used to make cakes, they are used to spread the chocolate cream on the cake, or in the same way, like you put the peanut butter on your bread, you just put here the GaNs paste. And then you put the wire inside and you start rolling it together with the paste very tightly. You just keep it rolling, rolling, and rolling until you finish the entire piece. Okay, such a palm size, it's enough, doesn't need to be much bigger. Then you take another piece of nano-coated copper wire, always the ends to be twisted back in this way to avoid energy loss. And then you just twist this over it. And if you did counterclockwise coils, then you make this also in the counterclockwise direction. Just I don't have enough long wire here. If you have longer to twist it more times until it's filled completely, it will be good. So we have an entry point and an exit point. So this about how to make capacitors.
Do you need to insulate it, Sander?
I can't believe you made it in 2 minutes, Sander. That was amazing. And people are loving it. Ruth says, love it, crash course in capacitors. She was one of the ones that was asking that question because she takes notes. So thank you very much.
Thank you, Sander. And what about the insulation, the distance between the capacitors? Is that's so it's 1 centimeter, 1.5, or between the capacitors? Well, that's what Mr. Keshe said. You need to, separate. They should not be in touch with one another.
So you leave some space.
And we need to leave this space soon, too.
Or this space, doesn't matter.
So we need to wrap things up for today, and there might be a few less loose questions, but that's all we can really handle, I think, for now. Anything else you'd like to say, Shandor, to wrap it up?
So thank you very much for participation. And tomorrow will be Wednesday, and on Wednesday morning we start again to continue the blueprint week.
That's
and
right.
hopefully, if you have made your MAGRAV systems, or if you have made some parts of it and not yet finished, please come and share with those photos and videos with us. So
Yes.
more people come, it's much better. Also, we have this blueprint website. Rick, do you have the exact
I have to pick that up. Just a minute here.
It's a blue.
The one that people can put their pictures on, you mean?
Yes, exactly.
Okay, let me see. I forget where that is.
It's a blueprint.keshefoundation.org.
Right.
Just I can't get in.
I've got it. I can share my screen here. Just a minute. And to let people know that this will be what we'll be doing tomorrow as a public workshop on the same channel, basically the blueprint channel.
Yes, and please don't send us pictures. Don't send us pictures. Don't send us videos. Upload your pictures, upload your videos on your favorite social media website. Does not matter in Baidu, on Google Plus, on Facebook, on YouTube, or on Vimeo. Does not matter. Just upload it to some public place where they can be shown without restriction, and just send by email the link to them. So send email to blueprint@keshefoundation.org. Please include your name, your location. For instance, I am Shandor. I'm from Budapest, Hungary, and here are my links. So you send the links to your Facebook page or YouTube page or Baidu or whatever. And then the webmaster will put up on this website on blueprint.keshefoundation.org your experiments and your results, and everybody can learn each from the other. That will be a great contribution.
And this is not to be confused with the other blueprint site that has the actual blueprints for the device.
That's linked on the upper right part is the MAGRAV's power blueprint link.
Right up here. So folks can see that. I can click on that. And that gives you the download link for the MAGRAV's Power Blueprints, it's called. This is version 2.0, and there'll probably be version 2.01 or 2.3, whichever upgrade we go for in the next little while. I'll try to keep that, I think, as a live document that gets upgraded as we find issues or discover new things that can be added to improve it as we go along. This is sort of a crowd sourced item in a way. We have manufacturers that are making it, but at the same time, many individuals too. So we can all collaborate to make a better product, I think. Okay, I think we should wrap it up for today. Thank you everybody for attending. It's Tuesday, November 3rd, and the afternoon teaching of the Keshe Foundation Spaceship Institute, and we'll continue tomorrow. Okay, bye for now. Stop the live stream.